I am Robert Oppenheimer. People most famously know, and honestly primarily remembered me for my greatest invention, the atomic bomb. After seeing the bomb in action, I quoted the Bhagavad Gita. Now I am become death, the destroyer of worlds. I was born in New York in 1922 on the 22nd of April. I grew up in an upper middle class neighborhood and took life easy. I grew up and graduated high school and went on to Cambridge and studied theoretical physics. I honestly was a bit too dedicated to my work and sometimes went prolonged periods of time without eating. I was awarded a fellowship at the United States National Research Council in 1927 at the California Institute of Technology, aka Caltech. I worked on many things such as nuclear physics, spectroscopy, and quantum field theory. In 1930, I wrote a paper that predicted the existence of the positron. I was also interested in other things non-science related. Religion, for example. I was fascinated with Hinduism, thus my favorite catchphrase from the Bhagavad Gita was created. But on to my most interesting piece of work, my part in the Manhattan Project. On October 9th, 1941, which was 2 months before the United States entered World War II, when President Franklin D. Roosevelt approved a crash test program for the atomic bomb when in May of 1942. Chairman James B. Conant, who was also one of my lecturers at Harvard, invited me to work on the fast neutron calculations, a task that I put my all into. In June 1942 was when the U.S. Army established and officially named the Manhattan Project, and the responsibility shifted from the Office of Scientific Research and Development to the military. In September, I was selected to head the project's secret weapons laboratory. Eventually, on July 16, 1945, the scientists, based in Los Alamos, New Mexico, saw the world's first nuclear explosion at a site near Alamogordo, codenamed Trinity. As I later recall that moment, I must quote the Bhagavad Gita. If hundreds of thousands of suns rose up at once into the sky, they might resemble the effulgence of the Supreme Person in that universal form. During the moments leading up to the explosion, the tension and weight I'd carried on my shoulders seemed to be getting heavier, and the tension seemed to build up by the second. And the second it went off, it was like I had the world's weight carried on my shoulders, and the bomb blew the weight up. Physicist Isidore Rabi noticed my walk and it later went on to say, I'll never forget his walk. I'll never forget the way he stepped out of the car. His walk was like high noon, this kind of strut. He had done it. I regretted not being able to make it in time to use on Nazi Germany. What's worse is it felt horrible when Nagasaki and Hiroshima and I felt as if it was my fault people died. I knew many people on the team felt the same way, so I went to take up my concerns with President Harry S. Truman. This made him mad, and he promptly ended the meeting. I found out later he told his Undersecretary of State, I don't want to see that son of a bitch in this office ever again. The Manhattan Project wasn't disclosed to the plebeian masses until the bombings of Hiroshima and Nagasaki. My invention is now used today as a form of violence, and I sometimes wish I could have said no and not made this weapon. I found out how to make this weapon with basic knowledge of atoms I had. You had to use uranium since they are naturally radioactive and would cause mass destruction. This is caused when the protons and neutrons desperately try to get rid of one another, and when they leave the atom, this is called radioactivity. Eventually, after giving out alpha, beta, and or gamma rays, they settle as lead. When a uranium atom is hit by a neutron, the uranium splits and releases a great force. This is called fission, and I based the bomb around this concept. When fission in uranium occurs, I found out this also creates two or three new neutrons. So perhaps they could be used in a chain reaction. After the neutron hits the uranium, the neutrons could hit other uranium atoms over and over and over again to create a huge explosion. For the bomb, we used uranium-235 and 238, mostly 238 with a little bit of more scarce uranium. What we did was use 238, which instead of fissioning, captured the neutrons and ultimately became plutonium, which is as useful for fissioning as uranium-235. We tried using a square brick of plutonium, but it didn't work as the neutron was captured and the other two went flying off. This wouldn't even be able to start a chain reaction. Our goal was to prevent the escape of the neutrons and make use of all of them. On one of our tests, the neutrons fissioned and kept going, but the energy it expelled would still not be enough to create a powerful bomb. To make this work, we needed to keep the neutron's birth rate higher than the death rate. To do this, we made plutonium into a sphere. This way we could maximize the working room and minimize the room for escape. To do this, we covered our bomb in a special mirror that will reflect the neutrons and turn them back into the collision area. Once we get a good chain reaction going, we get a supercritical mass. When this occurs, we have to try to keep the supercritical mass going until it is time for it to explode. We separate the plutonium from each other, and when the explosion is desired, we push them together quickly and keep them together long enough for a great number of fissions to occur. When this happens, there is less than a millionth of a second before it explodes. This is how the atomic bomb is made.